Hello guys, and welcome to yet another video in this series about competitive programming. Before we get to this video, I would like to notify you guys that I will not be having much time with you guys since my exams will be starting this week, and I'll need some time to set up and be ready for it. So I'll not be having enough time for you guys, but I will also try as much as possible to at least update weekly as much as I can and be consistent till after the exams, and I'll get back to updating or uploading videos 2 times in a week. So with that said, let's get back to what this video is about. So in this video, we are basically gonna just analyze a problem set from one of the reply, challenge, train and win problem sets. And if you don't know about the reply challenge, you can basically hop on to their site, which is challenge.reply.com. This link here, a link will be provided in the description box below, so you can check it out. And there will be a competition in this category, on the coding category, which will be coming up on the 11th of March. So you can enroll now and join a team or create yours and start preparing for the challenge that is to come. So with that said, we'll go back to the topic at hand. So in this video, as I said before, we're going to be analyzing this problem set from the reply challenge website. So this problem set is basically an X-ray related problem. I'm going to read down this problem set as fast as possible. If I'm too fast, don't be bothered, because I'll still take my time to analyze and explain how to approach this problem. So with that said, a fossil of the very rare species Canis lupus albus, considered to be the ancestor of the most common Canis lupus familiaris, has just been found. To analyze it, scientists must treat it with radiation. Every centimeter of bone must receive a precise quantity. The machine that does this treatment can apply radiation uniformly on a contiguous segment. Calculate how many times the machine must be operated to obtain the right amount of radiation on each bone point. So the details of this is, the bone to be treated is long n centimeters, numbered from 1 to n. The centimeter I must receive a quantity of radiation specified by a natural number Ri. The number n and the numbers Ru1 to Rn are input data. The machine is operated by specifying two positive integers a and b, which indicate the extremes of the bone segment on which the machine operates, where a is less than or equal to b. After this operation, all the centimeters from A to B of the bone accumulate 1 unit of radiation. After having driven the machine a certain number of times, the amount of radiation received on the centimeter I can be known by counting how many times a radiation has operated on that zone. That is how many times the machine has been operated with values such whose A is less than or equal to I and I is less than or equal to B. Calculate the minimum number of times the machine needs to be operated so that each zone I receives exactly the amount of radiation required, Ri. So here are the assumptions given. So in our input data, the first line of the input files contains an integer t, the number of test cases, followed by t test cases numbered from 1 to t. In each test case, the first line contains only integer n. The second line contains n integers separated by spaces R1 to Rn. The output file must contain the answers to test case you could solve. For each test case you have solved, the output file must contain a line with words case hashtag t equal k colon k. I think this is the format, basically. That's what I'm just trying to say here, where t is the test case number starting from 1 and k is the minimum number of times the machine must be operated. So this is an example input and output which have been given. So let's go right to the explanation. So here I'll over to notepad. So here we have written out the constant or the variables that we need to know, and we need to have at the back of our mind for us to go ahead with this problem. So we know that n from the question is the length of the bone. Please, if you have the question already in your phone, or in your device or any of your device, try to follow along. N is the number or the length of the bone. I is a specified centimeter of the bone, where RI is the quantity of radiation required by T, and the amount of radiation on I is equal to the number of times the machine operated on that segment, and A and B are equal to the extreme point of the segment. So these are the values. These are the values required, or the variables we need to know as we go on with this challenge. So in order to understand this further, I'm going to take into consideration that this species that is taken into consideration is a bone. Let's visualize it as a bone, and I will just indicate this bone with a square here. So this is our bone, and for our first test case, let's go back here. In the example, for the first test case, we know that this is the maximum number of test case, and this is the first test case, and also this is the second test case. For our first test case, we're going to look at all the values of radiations required on each segment. So we have that the values are 1, 2, 3, 1. So we'll go over to paint, and now we know that we have values 1, 2, 3, and 1. So let's indicate that 2, 3, and 1. So we know that this is the maximum number of radiation required on each segment, where the segment is equal to the index of each of these values. So our first segment will need a maximum of 1 radiation, a second segment will need a maximum of 2 radiation, and so on. So basically, let's look at all these segments as holes. So we'll have first hole, we have another hole, we have another hole, and we have another hole, and each of these holes are representing segments on this data. And to fill this first hole, a maximum of 1 radiation is to be applied here, and to fill the second hole, a maximum of 2 operations will be applied here. To fill the third hole, a maximum of 3 operations will be applied here, and the fourth, a maximum of 4 radiations. Please, I think I said operation instead of radiation. I said operation instead of radiation. So a maximum of 4 radiation will be required here. So what we're going to do in this case is that we're going to try to fill up all these. We're going to clean up this. We're going to try to fill up all this with our radiation. So the best approach is going to be to look at all this and put them into a segment, since we can actually go once in a row and add 1 radiation to all of these. So if we go once, we're going to have 1 radiation here, 1 radiation here, 1 radiation here, and 1 radiation here, and this will equal to 1 operation. And also we can see that this is filled, since this requires only 1 operation, but this part that needs 2 operations is not filled. The part that needs 3 operations are not filled. The part that needs 4 operations. So we need to continue going that way until we fill all these holes up to equal the maximum number of radiations required. So let's go over to our notepad here. So for our first test case, we have 1, 2, 3, and 1. We have 1, 2, 3, and 1 as the values, or the maximum number of radiation required on each segment, which we are going to visualize as empty holes that needs this particular amount of radiation to be filled up. So for this number of values given to us, the best way to approach this will be to look at the maximum possible way in which we can apply radiation to all of these at the same time. So we'll have one operation and one radiation in each of them. So what I mean is that we're going to look for a way to apply radiation to this, which would be applying radiation here, 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 and here. And for each radiation applied, we are filling up the holes here to try and reach this value, for each of the holes. And any of this radiation that has been filled, any of these segments that has been filled up to its maximum number of radiation, we will not consider that hole again. So that is what we'll do till everything gets to its maximum number of radiations. So after that is done, a very good approach that I love to follow when I'm doing this is to subtract 1 from each of these maximum values. So what would, if we subtract 1 here, this will go down to 0. If we are to subtract 1 here, this will go down to 1, this will go down to 2, and this will go down to 0 as well. And when this is done, we consider it as one operation achieved, meaning that we have applied one radiation here and there is no hole remaining. We have applied one radiation here at the same time and only one hole is remaining. We have applied one radiation here, only 2 holes are remaining, one radiation here, and only 3 holes are remaining. So in our file, they tell us that an operation is gotten when we move once against a portion in which we have chosen as a segment. So the portion we have chosen as a segment here will be A equal to 1 and B equal to 4. Sorry, B equal to 4, meaning that we chose from here to here as a segment, and this A and B is giving us the extreme point of this portion we have chosen, and what we're trying to fill is the portion in between these extreme points, which are all these holes. So if we're going back to our drawing, we'll see that this is our A and this is our B, and since that part is our A and B, we are trying to fill up holes, all these holes inside of that segment. So if we pick 2 as our A and our A will now be here, and pick 4 as our B, we'll try to fill up this portion, and this portion. Remember that A and B are inclusive into the portion we have chosen, or the segment we have chosen. So therefore, taking that into consideration, we have filled up the extreme points from what we have seen. So we'll go ahead and subtract 1. So going down to the next line, since this part is filled up, we'll represent it with a point or with a dot, and we'll reduce here by 1 as well, reduce here by 1 as well, or this will be 1, and reduce here, and here will remain the same, sorry. And another operation has been achieved where our A is equal to 2 and our B is equal to 3, because we're taking these 2 points into consideration since they are the only portions that have not been filled. And now we are going to go down again because we have one more portion that isn't filled. So we're going to go through and we'll reduce here by 1, and we're going to have one operation where we're taking A equal to 3 and B equal to 3 into consideration, since we know that our A and B are inclusive in our portions, so we can have this. So now, to know the maximum number of operations, we count our operations 1, 2, and 3. Therefore, our number of operations, our total operations, is going to be equal to 3, which is the sum of all the operations we have done. Now if we are to also consider this, let's say we have 2 and we have 4 and we have 0 and we have 3 and we have 4 and 5. So what we're going to look at and consider in this is going to be which portion isn't filled yet. And know that we can't include a filled portion into a segment, and we have 0 here, meaning that this portion has been filled already. Since this portion is filled already, we can't include it into a segment. Any portion, any filled portion can't be included in a segment. So since we know that any portion that is filled, since this is 0, we know that it doesn't have any holes again, so we can't include it into a segment, but we have to find the maximum number of segments and fill it up. So basically what we're going to do now is we're going to take these 2 portions into consideration as a separate segment and take these 3 into consideration as a separate segment. So what I mean by that is that first we're going to try to reduce the values on this side. So if we're reducing it by 1, we'll have 0 and we'll have 1 and we'll have 3. And we can't have this point affected because there is a filled portion in between, and we can't have one operation fill up all the points at once since there is an unfilled portion in between. So if we're analyzing that from our drawing here, we'll see that for all the points here, one operation will be carried out to fill it up once. So for all portions in between, or for all unfilled holes, or for all holes in between, one operation will be carried out to fill all of them at once. But if we have a filled hole here, therefore we'll have this part is filled, and since that part is filled, we'll have to take only this part into consideration first. Then we'll now take this part as well into consideration, ignoring the filled part. And when we're taking this part into consideration, we'll find out that one operation will be taken here, and another operation will also be taken here, totaling it to 2. Meaning that in order to fill the values here once, we have to take one operation. And in order to fill the values here once as well, we have to take another operation. Hope you understand what I mean. So going back to our values, we have filled this part, and this is one operation. We can't move on to this side because of it's not part of this segment here. So our number of operation here is going to be equal to one operation, where we're considering A to be equal to 1 and B to be equal to 2, since the third part is filled. Just look at it as a sequential mode of filling that, when we fill here, we fill here, and if here is already filled, when we fill here, we also have to fill here, and if here is already filling, we have to just go back and start refilling here until all these parts are filled before we now affect these areas. And I hope that is understandable. So we go again, because these have not been filled, the parts or this segment here has not been filled. So we'll go again, this will be reduced to 2, and we'll have our dots again, and we'll have one operation accomplished, where we're still taking this segment into consideration, because we have not accomplished we have not filled all the holes in between that segment. So we go down again, this part is really filled, so we'll not consider it again, and here will be 1, and we'll have our dot, So we'll have one operation. Now from here we'll take only this part into consideration. So we'll go down and have dot here, and this will be filled, and since that part is filled, other parts will remain the same, but one operation has been carried out where a is equal to 2 and b is equal to 2. Then if we go down further, we'll see that we have filled all these parts at the beginning, so we can go ahead and start filling up parts here. So what we'll do is reduce this to 2, this to 3, and this to 4. We'll have one operation considering a to be 4 and b to be 6, right? Yeah, and we'll do it again. 1, this will be 2, and this will be 3. Here we're still considering the same number of the same segment, so another operation has been carried out, and we'll go again for another operation since we still have values or holes to be filled. So this will be reduced and this will be reduced as well. So one operation has been carried out. Now we're going to consider a new segment, but this part is already filled, so we have that already. And here we're going to consider this segment now and reduce it as well. One operation has been carried out where a is going to be equal to 5 and b equal to 6. Then we'll go again and reduce this to 0. One operation has been carried out where a is equal to 6 and b equal to 6. So therefore we have accomplished all this, and we can now add, or we can now sum up all the number of operations. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So our total number of operations will be equal to 9. Now if we're looking at what we are doing here, we find out the more the values we have, the more values we have, or the more segments we have in between the bone, the harder it is to get, and the more we have filled segments in between each and the more we have filled holes in between each portions, the harder it will get for us to fill it up. So if I were to write a program or a code to continually reduce with respect to what we have here, we'll find out that code is going to be so consuming on our PC as a whole. So we have to find a mathematical way of solving this, and a good way which I kind of found is to look at this. When we look at this, we find out that if we have only 2 segments into consideration, what we want to do is to pick the maximum value, because the maximum value will give us the total number of operations to go for that segment. So that means we're going to put our values, the considered segment, into a list, and for that list we'll pick the max. Let's call this a list. We'll pick the max of this list. We'll pick the max of the list, which is going to give us 4, and we're going to add 4 to our total number of operations. So at first we'll initialize our total number of operations, which I will call TO, to be equal to 0 at first. Then at this point, after we get the maximum value, we're going to increment our total number of operations by that maximum value we got in the list, and so we're going to have TO plus equal to 4. So therefore we'll increment our total number of operations, and we will not consider this list again since we have gone for the maximum value, and this will give us the maximum number of operations that will happen in this list. If we want to check it, we can see that we'll have this reducing to 1 and this reducing to 3, and again we'll have this reducing to 0 and this reducing to 2, and again we'll have this is filled already and this will reduce to 3. This is filled already and this will reduce to 1, and we'll have the same but here reducing. And now if we count the maximum that occurs here in this segment, we have that this is 1, 2, 3, 4. So 4 is what we're going to pick, which is the maximum. Now again, we'll now look at here, we'll now find out that we can have a list that is greater, that its length is greater than 2. So first here we're meant to consider the length. I missed a step here. Consider the length of our list, and if greater than 4, if the length is equal to 2, then we do this, we carry out this step. Now if the length, we have a list like 3, 4, 5. So if you have a list like this, what we're going to do is first consider the length of that list. If it's greater than 2, now what we want to do is loop through the list and subtract each of them by the minimum number. So we'll find the minimum number in the list, the minimum value of the list, and when we find the minimum value in this list, what we're going to do is subtract each value by that. So I'll go to the next line here. So I'll subtract each value by the minimum. So this will be 3 minus 3 and 4 minus 3 and 5 minus 3. And after we've done that, we'll get a new list which will look like this: 0, 1, 3, right? 0, 1, 2, sorry. So when we get a list that's looking like this, what we want to do is write a code that will remove 0 from this list. We'll remove 0 from this list, and we'll find a way of removing 0 from the list. So our list will now look something like this. Then again, we go back to this first step here. We go back to this first step and check the length. If the length is equal to 2, as this is stated, we know we're going to pick the maximum. We're going to pick the maximum value in the list, right? But if it is still greater than 2, we are going to perform the same operation we performed again and subtract by minimum value. But something to do after subtracting by the minimum value, something we must do is to increment by the value, increment our operations by that value we subtracted by. So we're going to increment by 3, since we subtracted by 3 in that segment. So we already have TO to be 4 already from here. We'll increment it by 3 here, and when we do that, we'll check the list and we'll find out that the maximum will be 2. That is with respect to our step 1. With respect to step 1, which will be here. With respect to step 1, we'll find out that the maximum will be 3. So this is step 2. So we'll find out that the maximum will be 3. So what we're going to do again is to increment our total number of operations by that maximum value again, the maximum will be 2. So we increment by that value again, and when we add up everything here, our total number of operations will now be equal to 4 plus what do we increment by? Plus 3 plus 2, right? Which is going to be equal to 9. Now when this has been done, we find out that we have gotten the value we required, because we have solved for both segments. We solved for the first segment here, which is this part, and we solved for the second segment here. which is this part, and we have gotten the values and added the total number we got from here and the one we got from this step 1 as well. So before any of these processes are taken out, make sure you loop through your array or your list, and make sure and divide the list to a sublist. Now the way you do this is, when you loop through your list, you find out where a 0 value occurs, or where the maximum number of radiation is 0, meaning that our holes are already filled, and we'll slice the list there and take the portions where 0 is not going to be included. So what our new list will look like would be something like 2, 4, and 3, 4, 5. So basically this is what our new list will look like when we have divided into sublists, and then we'll go through these steps for each list. So if you approach a list, you check step 1. If the condition for step 1 is not met, which is this, you go for step 2. If the condition for step 2 is met, you perform the task for step 2. And when you perform the task for step 2, you check step 1 again and see if your value or your new list you get is equal to what you have in your step 1, whether your new list matches the condition in your step 1. And if it matches the condition, you go ahead here and finish up. But if it doesn't, you repeat your step 2 for that again and do. So this is like a recursion which you continue calling step 1 where you continue calling step 2 if the condition for step 1 is not met. So that is basically what we're going to do here, and we will see that this is very well correct. Let's just look at one more example and we'll be done for this video. So we have the second example that was given here is this one with 100, 0, 1, 1. So let's take that into consideration. 100, 0, 1, and 1. So if we take that into consideration, we're going to look here. We see that we have only 1 here and we have 2 here. So let's go for our step 1. If we're to follow our step 1, we check the length of the list. And if we check first, before we actually go for our step 1, we have to divide this into sublists, which will look something like this: 100 and 1 and 1. Now, so if we have something like this, we'll have to loop through each list. When we loop through this list, we're going to check if it satisfies any of the conditions in step 1 or step 2. So now we find out that this won't satisfy any of the conditions. So, but something to have at the back of your mind is that if the value is equal to, if the length of that list is equal to 1, just add that whatever value you have inside that list to your total. So let's just include one more step here. We'll name it let's just name it step 0, following the indexing of computers or programs. So for step 0, what we're going to do is look at the list. Let's assume that we have a list with only 1 property. This is an assumed value. Let's assume. So if we have a list of only 1 value, what we'll do is our total operations will be incremented by that value that is inside that list. So if we are taking that as a step, we'll pass this through the step 0, and when we pass this to step 0, we'll find out that for the first list, which is containing 100 as the only integer in its list, what we're going to have as value is going to be our total plus equal to 100. So remember that we have to initialize our total operation to be equal to 0. So we increment our total. So we find that the condition for step 1 is met, and what we're going to have is first 1 and 1, and what our step 1 would return to us will be TO plus equal to 1, since we have that our maximum is going to be 1 in this situation, and so our total operations is equal to 100 plus 1, which is going to be 101. So we find out that if we go back to what is given here, we'll find out that we got the right answer here. So guys, that's it for this video. I hope you understand the analysis. You should try to write up the code, and in my next video I'll be writing the code for this program, or for this problem. I'll be writing the algorithm that is going to solve this. There's going to be a little trick that we have to satisfy while writing the code, but try it out and tell me where you have problems in the comment section, and I will try to attend to you guys as fast as possible. And remember, I have exams, so if I don't attend to you guys that fast, you know that I was busy or something. So don't forget to like, comment and subscribe, and I'll see you guys in the very next tutorial.